If you base your understanding of artificial intelligence on Hollywood science fiction, you likely picture it locked away, a highly dangerous, tightly guarded machine kept in a cold room by people who know something the rest of us don't. That perception reflects a very real tension in the modern economy. The data and the algorithms driving this technology are immensely valuable, and they are overwhelmingly controlled by a handful of massive tech corporations. But in 2011, one of the world's top AI researchers made a completely counterintuitive decision. He took his highly exclusive, incredibly expensive Stanford University lectures and uploaded the recordings to the internet for free. His name is Andrew Ng. His story reveals how machine learning transformed from a niche academic pursuit into a global industry because he chose to operate as both a corporate pioneer and a public educator at the exact same time. On one hand, he sat deep inside the world's most powerful corporations, building elite systems from the ground up. On the other, he actively tore down the walls around that knowledge so anyone with an internet connection could see exactly what he was doing. By revealing the inner workings of a trillion-dollar industry, he effectively decentralized control, ensuring the future would be built by a global community rather than a few corporate monopolies. Ng's credibility on the corporate side is difficult to overstate. He founded the Stanford Artificial Intelligence Lab, and by 2011, he was inside Google, launching the division known as Google Brain. It was there that his team tackled one of the defining experiments in early machine learning, the digital cat. The goal was to see if a system could learn like a human child. You don't hand a toddler a manual detailing the geometric proportions of a feline. You just show them a bunch of cats, and their brain recognizes the pattern. Ng's team tested if a machine could do the same, without explicit programming defining what a cat actually was. By feeding the system millions of random YouTube frames, the neural network identified a cat entirely on its own. It proved that deep learning models could solve complex, unstructured problems, provided they had enough data and raw computing power. In 2014, he moved to Baidu to apply these same neural network strategies on a massive scale. As chief scientist, he built their AI department from scratch, driving major advancements in Chinese speech and image recognition. Between Google Brain and Baidu, Ng verified that the algorithms were sound. The math worked. The actual bottleneck holding the entire industry back was a severe shortage of engineers who actually knew how to write the code. Ng is famous for calling AI the new electricity, but electricity is completely useless if nobody in the world knows how to wire a house. He had already noticed this discrepancy back at Stanford. When he put those informal lecture recordings online, he discovered something incredible. While he was teaching a few hundred enrolled students in his classroom, over 200,000 people around the globe were watching the tapes. To solve this access problem, he partnered with his colleague Daphne Kohler in 2012 to launch Coursera. Within the first 30 days, enrollment in his machine learning course exploded to 100,000 students, reaching learners across Africa, Asia, and Latin America. Today, Coursera hosts over 148 million learners worldwide. Ng expanded on this by creating DeepLearning.AI, a platform specifically targeting the highly technical engineering skills required to maintain modern neural networks. He looked at the massive scale required to train a machine and applied that exact same logic to human education. He deliberately engineered the global workforce required to sustain the industry he helped create. Because of that parallel strategy, machine learning is no longer an isolated experiment locked inside a few server rooms in Silicon Valley. It is a globally accessible tool being actively refined by millions of developers. Yet, as these systems get more capable, the primary public response is often anxiety. There is a persistent worry that these algorithms will completely automate human labor and render entire workforces obsolete. Acknowledges that legacy roles will disappear, but argues that new, unforeseen jobs will replace them. The friction we feel isn't caused by the technology itself. It is driven entirely by how slowly our labor markets adapt to new tools. His advice is straightforward. Don't try to learn everything. Learn how to learn. In an economy moving this fast, a static skill set is a liability. Continuous education is the only reliable survival strategy. Na's most significant contribution goes beyond the code for the digital cat. He created the infrastructure for global knowledge transfer, allowing anyone with an internet connection to build the next breakthrough. While the tools of AI will continue to evolve, their ultimate value depends on the people who use them. The most durable investment remains the human mind.